Kia ora Year 9. This is the first video that I'm making for students who are really confident with the numerical properties work we're doing in this topic. So I've decided the first topic I'm going to do is all about SURDS. Now some of you are probably thinking, what is a SURD? I've never heard of that. It sounds funny. This is going to be the first video. There'll probably be a series of these. So the way I want you to use this is to have your maths book out and take some notes as you go when you get to the mathsy bits. I'm calling this Year 9 extension because this work is going to be quite challenging and it's definitely not going to be tested in Year 9. I want you to do it just for fun. And we might do some problems looking at SURD stuff in Maths Club on Mondays. So what's a SURD and how do we work with SURDs? So the most famous SURD is this one here, the square root of 2. And the square root of 2 is an irrational number. There's no way that you can write the square root of 2 exactly using a decimal. So if you go and grab your calculator, you'll see you get a whole bunch of numbers when you chuck it in your calculator. You'll get 1.41 da 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 da, but that is just an approximation. So some of you are probably going, well, really, how important can they be if this number can't be expressed exactly? But SURDs come up everywhere in real life. So here's the first place that you might be able to find your own SURD. If you're watching this at home and you've got a piece of chalk and a big ruler, you can go outside, ask your parents first, and you can rule out 1 metre here, a 1 metre line here, and then at a 90-degree right angle, you can do another 1 metre line with chalk here. Then, if you're into maths, probably the thing you want to do is to make that into a triangle. So if we grab our ruler and try very hard to join up the dots. So you can do this in real life. I'm just going to do it here. We're going to get a line that goes down here like this. And the length of this line, if you could measure it really exactly, would be the square root of 2. Now there are all these links here to Pythagoras Theorem, and if you're watching this you probably already have a few clues about Pythagoras, but the idea is that the square root of 2 does come up all the time, and so do other SURDs. So these irrational numbers are pretty special in maths. And I'll give you a couple of other ones that you'll already know, maybe pi, and another one which is e. If you're interested, you can go away and look up on the internet, go and look up both of those numbers. There are some fantastic videos. One of my favourite series is the Numberphile videos. And Numberphile's done quite a lot of videos about all three of these numbers. But today, what I want to do in here is to get us using SURDs and being able to manipulate them, just like we do with fractions or integers or any other kind of number that feels really easy. So, here are our first rules for SURDs. We've got 4 little rules that are going to take me a long way. And the first one is this. If I've got the square root of a squared number, I get back to the number. For example, the square root of 4 is equal to the square root of 2 squared, which is just equal to 2. You're probably thinking that one seems pretty obvious, and it is. But it's the first time some of you might have heard of an inverse operation in maths. So square rooting and squaring are inverse operations. One operation undoes the other one. Just like we have times and divides, and we have addition and subtraction. So now we have square rooting and squaring. The next thing is that if I take a square root of a number and I square it, I get to the number. Again, it's pretty obvious. But when we do maths, we like to start with things that are pretty obvious and then see how far we can build them up. So if I have the square root of 3 times the square root of 3, even though these two things are irrational, multiplied together, they're going to give me 3. The next one is where we start to have a bit more fun. The square root of a times the square root of b is the same as the square root of a times b. And the fourth rule is this. If I have the square root of a divided by the square root of b, that can be written as the square root of a over b. So what I'd like you to do at this point is to just jot those rules for SURDS down into your maths book. So copy them down neatly because we're about to start using them. So let's look at how we can start to simplify SURDS. When we're working with SURDS, our goal is to get the number under here as little as we possibly can. So if you're told to simplify the square root of 80, you might be looking at it and going, well, what's wrong with the square root of 80? The thing is, we can make the number in here smaller as follows. And I call this hunting for squares. So the square root of 80 can be written as 5 times the square root of 5 times 16. Now if you look at that third SURD rule, we have the square root of a times the square root of b is equal to the square root of those two things times together. So we can write the square root of 80 as the square root of 5 times the square root of 16. Now we can't do anything with the square root of 5, but the square root of 14 is equal to 4. So that's what we mean by simplifying the square root of 80. And we get 4 times the square root of 5. But we have a convention in maths that we don't need to write that times sign, and in fact that doing it will confuse people. So we just write it as 4 root 5. So the goal here was to go from having a really big number under the SURD sign to having the smallest possible number under the SURD sign times by a multiple. So I'm going to do another one and then give you some to try. So let's try and simplify. Oh, what happened there? Don't know what that was. Simplify. Let's do this number, 125. So again, we're going to go hunting for squares. We're going to look for factors of 125. Well, we can write 125 like this. 5 times 25. 25 is a square number. So that's 5 times 5. Sorry, 5 times the square root of 5. So that's that one done. Alright, now it's your turn. So I'm going to give you 4 questions. You can write them in your book, but leave lots of space because we might have to come back and fix some things up. So the first one is to simplify the square root of 32. So we're looking for squares. Remember, always on the hunt for squares. So we try to get the highest possible square we can. We can write this as 2 times 16. The square root of 16 is 4. So this becomes the square root of 2 times 4. And we write that as 4 root 2. Now pretty soon you'll be able to go from this step straight to this step. So this step is kind of optional. Next one. 50 is equal to 2 times 25. So that's the square root of 2 times the square root of 25, which is equal to 5 times the square root of 42, a square root of 2. Now, what about number 3? Here's the square root of 243. We might need to do a factor tree for this one if you can't quickly think of a square that's in there. So a factor tree would help us figure out square factors. Let's have a quick look at what's going to work. Well, one's a factor, that's no use. 2's not a factor because it's not an even number. Is 3 a factor? Well, a really easy way to check that is to add up the digits and see if it's a multiple of 3. 2 plus 4 plus 3 is 9. So that's a multiple of 3. 3 is going to be a factor. 3's here and 81's here. Well, that's perfect because 81 is a squared number. So 243 is equal to 3 times 81, the square root of 3 times 81, which gives me 9 root 3. So hopefully you're starting to get the idea by now. The last one was the square root of 180. And we can write this as 9 times 20. And this is one that we're going to do in a couple of steps. So that gives me 3 root 20. But we can do better than that because 20 has got a square lurking in there. It's 3 times the square root of 5 times 4. So we can take out the 4, so it's going to be 3 times 2 root 5, which is 6 root 5. So that's the first type of simplification of SURDS. Right? We're going from a big number here down to a small number under the SURD sign here. There's one more thing I want to show you in here, which is how we can simplify the product of two SURDs. I think you'll find this easier, so do each one of these as we go. Just pause the video and have a go at it. Remember, our rule is that root A, root B, times root B is equal to AB. So root 2 times root 5 is equal to the square root of 2 times 5, which is the square root of 10. The next one we're going to do is the square root of 2 times the square root of 8. So pause the video and have a go at it now. Okay, so what we will get there is that we can times the 2 and the 8 together and we get the square root of 16. But that's just equal to 4. So sometimes these SURDs simplify down really well, and sometimes not quite so well. So the square root of 3 times the square root of 24 is going to be equal to the square root of 72. Look for the lurking square in there as a factor. We've got 2 times 36, which is equal to 6 root 2. Number 4, the last one for this video, is 5 times square root of 5 times the square root of 15, which is the square root of 45. Now just notice before I finish up that this one can't be simplified and this one can't be either, but when I multiply them together, what happens is that I've got a lurking square in here, because this is equal to 5 nines, which is equal to 3 root 5. So there you go. Thanks very much for watching. 12 minutes is quite a long video for me, so congratulations if you made it to the end. There are going to be some tasks that go with this that I'll pop into our Google Classroom later on today or tomorrow. Please let me know if you've got any feedback, and I will catch up with you in class if you watched it before then.